Everyone, so I'm doing question 4.1.11d. So we're given two sets, A and B, and we're given this function, this big X, where if an element X is in this set, the function is 1, and if it's not in the set, it's equal to 0. And this applies for the union of A and B, it applies for the set A, and it applies for the set B. So the first scenario, there's 4 different cases in this question, and I did a proof by exhaustion, I suppose, because I exhausted all these cases. And the second and third case are the same, pretty much. The first case is in which our element X is in A and B. Our second and third case is which our element X is only in one of those sets. And the last case is in which the element is in neither of those sets. So basically, we are just going to have to keep doing this equation, x of ax, xax plus xbx minus xax times xbx. And we know that the value of those is going to be 1 or 0, depending or not whether or not our element is in that set. So I'm just going to do quickly the first case, the union of A and B. So we know our element X is going to be in both A and B, as we stated before. So xa of x will be 1, xb of x will be 1, and we'll be subtracting that by xa of x times xb of x. So that's going to be 2 minus 1, which is 1, and we know xaubx is equal to 1 because our element is in that union. It's in both sets, so the function holds. And we're just going to keep doing that for each of the cases, and it's really simple, and it's just arithmetic at that point. But of course, you should be getting 1, 1, 1, and 0 for each case. So 1 if it's in both sets, 1 if it's only in set A, 1 if it's only in set B, and 0 if it's in neither of the sets. Which makes sense because it won't be in the union if it's in neither of the sets. If it's in one of the sets, it'll still be in the union. But our arithmetic will be a little different, but you'll still get 1 at the end. And that's it. That's the whole proof.